We can use hypothesis testing to determine whether the sample correlation coefficient, R, provides enough evidence to conclude that the population correlation coefficient, Rho, is significant. First, state the null hypothesis and the alternative hypothesis. Now, the null hypothesis always states that Rho is equal to 0, so no significant correlation. The alternative hypothesis always states that Rho is not equal to 0, meaning there's significant correlation. Next, we have to identify the level of significance, then enter the data into the lists, and then go to the Tests menu and select the Linear Regression t-test. Then make our decision and conclusion. The number of passing attempts and passing yards for 7 professional quarterbacks for a recent regular season are listed below. At alpha equal to 0.05, is there enough evidence to conclude that there is a significant linear correlation between passing attempts and passing yards? The null hypothesis is that Rho is equal to 0. The alternative hypothesis is that Rho is not equal to 0. Alpha is 0.05. We need to enter the X list into L1 and the Y list into L2, and then select Linear Regression t-test. So press Stat, Edit, enter in the list, and then press Second Quit. Then go back into the Stat menu, go over to Tests, and then down to Linear Regression t-test. So the X list is L1, the Y list is L2, the frequency is 1. This is a two-tailed test, and we can press Calculate. So T is equal to 16.295, and the p-value is 1.587 e-5. The picture looks like this, and the p-value is less than alpha, so we reject the null hypothesis. And the conclusion would be, at the 0.05 level of significance, there is enough evidence to conclude that there is significant linear correlation between passing attempts and passing yards.